Hi, this is Tutormalvis. Based on popular demands, I'm making this video on limits. Limits are fundamental in calculus, alright? Because they help us to understand the behavior of functions at specific points. So what exactly is a limit? A limit describes the value that a function approaches as the input or variable approaches a certain value. If f of x, for instance, is a function and c is a number, I can say that lim f of x as x tends to c equals to L. So what I'm simply saying is the value of f of x as x approaches c is L. So this is the basic idea about limits. Now, for us to appreciate how to use limits and what it stands for, we need to check the properties of limits, okay? So let's look at the properties that we need to be familiar with. Properties of limits. You can also call them the laws of limits, okay? So the first, we have the sum law, where lim f of x as x tends to c plus lim g of x as x tends to c will give us the limit of the sum of the two of them as x tends to c. What does this law state? It states that if you know the limit of two functions like this, alright, f of x and g of x as x tends to c, you can find the limit of their sum by simply adding the two limits together. Then number two, we have difference law. Difference law. And this is very similar to sum law. If you know the limits of f of x and g of x, alright, you can find the limits of their differences by subtracting the limit of gx from the limit of fx. So how do we do that? Let's say you have lim f of x as x approaches c minus lim g of x as x approaches c. It is the same as the limit of their differences, like this, as x approaches c. So this is difference law. The third one is the product law. The product law of limit. If you have lim f of x as x tends to c multiplied by lim g of x as x tends to c, you can simply have the limits of their products, alright, as x tends to c. So the fourth one after the product law is the constant multiple law. constant multiple law. All right, and that states that if you multiply a function by a constant, the limit of that product is equal to the constant multiplied by the limit of the function. So let's say lim k times f of x as x tends to c is equal to k lim f of x as x tends to c, where k is a constant. So this is the constant multiple law. Let's look at the quotient law. That's the fifth one. Quotient law. What does the quotient law state? It states that the limit of a quotient is the quotient of the limit, as long as the limit of the denominator is not 0. So, if we have lim f of x all over g of x as x tends to c, you can simply have the limit of f of x as x tends to c over the limit of g of x as x tends to c. And this is provided that the limit g of x as x tends to c is not equals to 0. Okay, let's check power law. Power law of limits. If you raise a function to a power n, the limit of that power is equal to the limit of the function raised to that power. So let's say this is lim f of x, all right? Everything to power n. As x approaches c, it will be the same as the limit of f of x all raised to power n as x approaches c, provided that n is a positive integer. Okay, let's check the last one, and that is composition law. Composition law. Now, in composition law, if the limit of f of x as x tends to c equals to L, and the limit of g of x as x tends to L equals to m, then we can conclude that the limit of g into f of x as x tends to c is equals to m. So these are the basic laws or properties of limits that we need foundationally to solve questions in limits. So let's see questions where we can appropriate some of these properties so that we can know how best to use them. Let's look at examples that will help us understand the laws better. We are told to find the limit of 3x plus 5 plus 2x minus 1 as x tends to 2. So simply, we are going to split this using the sum law. So that will be the limit of 3x plus 5, all right, as x tends to 2, plus the limit of 2x minus 1 as x tends to 2. So the meaning of x tending to 2 here is wherever you see x, you put 2. So this will be 3 into 2 plus 5 plus 2 into 2 minus 1. So this is 3 multiplied by 2, 6, 6 plus 5, 11, plus 2 multiplied by 2, 4, 4 minus 1, 3. So we have 11 plus 3, and that is 14. So the limit of this function is 14. And that is how to apply the sum law. Let's say another example. Example 2. Let's say we have the limit of x squared minus 4, all right, minus 2x plus 1 as x tends to 3. So this will be the same as the limit of x squared minus 4 as x tends to 3 minus the limit of 2x plus 1 as x tends to 3. So wherever you see x, you put 3. So this becomes 3 squared minus 4 minus, put x for 3, or 3 for x rather. Anywhere you see x here, you put 3. 2 into 3 plus 1. 3 squared is 9. 9 minus 4 is 5. Minus 2 multiplied by 3, 6. 6 plus 1 is 7. So this is 5 minus 7. You have negative 2. So the limit of this function is negative 2. This is what we call the difference law. Okay, let's take example 3, where we can apply the product law. If we have the limit of 2x multiplied by x plus 3, all right, so as x tends to 1, according to the product law, we can have the limit of 2x as x tends to 1 multiplied by the limit of x plus 3 as x tends to 1. So limit of 2x as x tends to 1 will be 2 into 1 multiplied by 1 plus 3. So 2 multiplied by 1 is 2 times 1 plus 3, that is 4. 2 times 4 will give us 8. And that is that about that question. So let's see how to deploy the quotient law. If we are to find the limit of x squared minus 4 over x minus 2, all right, as x tends to 2. Now, what we need to do first is we need to factorize this numerator, because if we simply say that this becomes the limit of x squared minus 4 as x tends to 2 all over the limit of x minus 2 as x tends to 2. So, if we do this and we simply substitute 2 for x, that will be 2 squared minus 4 over 2 minus 2. So that will be 2 squared, that's 4 minus 4, that is 0 over 0. Now, this will be very wrong, all right, because I already gave you a condition under quotient law that your denominator cannot be 0. All right, and that is why this is wrong. So what are you going to do if you have this kind of question? So it's going to be the limit of the numerator, x squared minus 4 as x tends to 2, all right, divided by the limit of the denominator, x minus 2 as x tends to 2. So what we are going to do simply is factorize this using difference of two squares. So that will be lim x squared minus 2 squared, all right, all over lim x minus 2. So this is at x tends to 2 at x tends to 2. And this will give us the limit of x minus 2 into x plus 2 as x tends to 2. All right? All over the limit of x minus 2 as x tends to 2. Now that you have this, you can use product law for the numerator and split them. So that will be lim x minus 2 as x tends to 2 multiplied by lim x plus 2 as x tends to 2 all over the denominator, that is lim x minus 2 as x tends to 2. So you can strike out this limit and this limit. You are left with lim x plus 2 as x tends to 2. So you can now substitute 2 for x. So this will be 2 plus 2 and you have 4. So for this question, this is the correct answer. Then the next one we want to check is the constant multiple law. Let's have an example on that. If we have lim 5x squared as x tends to 0, it's going to be the same as 5 multiplied by the limit of x squared as x tends to 0. All right? So if x is tending to 0, wherever you see x, you put 0. So that is 5 multiplied by 0, and that is what? 0. So the answer to this question is 0. So let's check the power law. The power law. If we have the limit of x plus 1 all squared as x tends to 3, all right, so it's going to be the limit of x plus 1 as x tends to 3 all squared. So the implication here is you substitute 3 for x. So that will be 3 plus 1 all squared. That is 4 squared. And that will give us 16. So the answer to this function is 16. All right, let's check the 7th question. And in this question, we are going to be applying the composition law. Let f of x be equals to 2x plus 1 as x tends to 1, and g of x equals to x squared as x tends to 3. find the limit of g into f of x as x tends to 1. So the first thing we need to find is f of x equals 2x plus 1 as x tends to 1. So this would be, anywhere you see x, you put 1. 2 into 1 plus 1, and that is 3. Then next, we need to find the limit of g into x, alright, equals x squared as x tends to 3. Meaning, anywhere you see x, you put 3. So that is 3 squared, which is 9. So using composition law, the limit of g into f of x as x tends to 1 must be equals to 9. So let's proceed to talking about the standard limits. The standard limit, just like in differentiation and integration, we have standard, differentials and standard integrals. So we also have standard limits like constants, all right? So let's look at them one after the other. So the first I will talk about is limit of a constant. The limit of a constant, where if you have the limit of k as x tends to c, the answer is going to be k. That is, the limit of a constant is the constant itself. Example, if I have limit of 7 as x tends to 2, all right, the answer to this is 7. The limit of a constant is the constant itself. Don't forget. Then number 2, let's talk about the limit of identity. Limit of identity. If we have the limit of x as x tends to c, the answer is going to be c, meaning that wherever you see x, you put c. This simply means that the limit of s as x approaches c, alright? So if I have the limit of x as x approaches 3, so wherever I see x, I will simply put 3. This is what is called the limit of identity. Okay, let's look at the third one. Limit of polynomial functions. Limit of polynomial functions. Now, what's the limit of polynomial function? If you have the limit of ax to the power of n, for instance, bx to the power of n minus 1, and so on and so forth to z, as x tends to c, we are going to have a multiplied by c to the power of n plus b multiplied by c to the power of n minus 1, and so on. Okay, how do I apply this constant? So let's say we have this question. Let's say we are asked to calculate the limit of 3x squared plus 2x plus 1 as x tends to 2. So basically what we are going to do is just substitute x equals to 2. So that anywhere you see x, you put what? 2. So this will be 2 squared plus 2 into 2, then plus 1. 2 squared is 4. 3 times 4, that is 12 plus 4 plus 1. 12 plus 4 is 16. 16 plus 1 is 17. Therefore, the limit of 3x squared plus 2x plus 1 as x tends to 2 equals to 17. Number 4. Let's see the one involving e. Limits involving e. If you have the limit of e raised to power x minus 1 all over x as x tends to 0, the answer is going to be 1. So this is a constant, don't forget, and we are dealing with standard limits, all right? So this limit equals 1 as x approaches 0, reflecting the derivative of e raised to power x at x equals to 0. So let's check the fifth one, and that is the one involving sine. Limit of sine x over x as x approaches 0 is equals to 1. All right? So this limit approaches 1, indicating that sine x behaves like x near 0. So let's check the sixth one. That is the one involving tan. Very similar to that of sine. So tan x over x, the limit of tan x over x as x approaches 0 will give us 1. Then limit of natural logarithm. Limit of ln x over x minus 1 as x approaches 1 is equals to 1. Number 8. Limits involving 1 minus cos x all over x squared, all right, as x approaches 0 will give us 1 over 2. So it's very important that you become familiar with these standard limits. So let's look for the limit of exponential function, because as we proceed we are going to encounter questions where these properties will be needed. So the limit of 1 plus 1 over x all to the power of x as x approaches infinity is equals to e. And this is what we have under standard limits. So let's see a few questions under limits and how to solve. So let's practice these questions together. Question 1. Evaluate the limit of x squared minus 5x plus 8 as x tends to 3. So this is the same as saying lim x squared, all right, as x tends to 3 minus lim 5x as x tends to 3, then plus lim 8 as x tends to 3. All right. So here you substitute 3 for x. That will be 3 squared minus 5 into 3 plus. Don't forget what we said about the limit of a constant. It will give you that constant. So here you write 8. So this is 3 squared, that is 9, minus 5 times 3, that is 15, plus 8. So basically we have 9 plus 8, that is 17, minus 15, and that is 2. So the answer to question 1 is 2. Question 2, we have the limit of this. So basically we are going to have lim the numerator, all right, as x tends to minus 1 divided by the limit of the denominator as x tends to minus 1. So for the numerator, anywhere you see x, you put minus 1. That's 3 into minus 1 squared minus 2 into minus 1 minus 1. Then for the denominator, you put minus 1 all squared plus 3. So minus 1 all squared is 1. 1 times 3 is 3. Then minus times minus is plus. We have plus 2 minus 1 all over minus 1 all squared is 1. 1 plus 3, that is 4. So we have 3 plus 2, 5. 5 minus 1 is 4. 4 divided by 4 is 1. So the answer to this question is 1. Option A. Then question 3. Similar approach. We have limit of 15 minus x squared plus x cubed as x tends to 3 all over the limit of x to the power of 4 minus 15 as x tends to 3. So wherever you see x, you put 3 and you leave the constant term. 15 minus 3 squared plus 3 to the power of 3 all over 3 to the power of 4 minus 15. So this is 15 minus 9 plus 27 all to the power of 3 to the power of 4 is simply 81. So that is 81 minus 15. So we have 15 plus 27, and that will give us 42. 42 minus 9, that is 33. All over 81 minus 15. We have 66. So we can cut 3 here 1, 33 here 1, and 33 is 66. We have 2. So the answer to this question is half. In question 4, we are told to evaluate lim 3 minus 2 sine x as x tends to pi over 2. So this is going to be the limit of 3 as x tends to pi over 2 minus the limit of 2 sine x as x tends to pi over 2. Anytime you take the limit of a constant like this, you have that constant. So this is 3 minus, we have 2 sine, anywhere you see x, you put pi over 2. Alright, in calculus, pi has the value of 180. That's 180 radian. 180 divided by 2 gives us 90. So this is 3 minus 2 sine 90. And sine 90 is 1. So 2 times 1 is 2. 3 minus 2 will give us 1. So the answer to this question is 1. Option B. Alright, we have question 5. Evaluate 2x squared minus 7x minus 4 all over x squared minus 16. Looking at this, since our limit, our x approaches 4, it will be wrong for us to just say this is 2 into 4 squared minus 7 into 4 minus 4 all over 4 squared minus 16. Alright? Because at the end of the day, your denominator is going to amount to 0, which is a sin in limit. So what are you supposed to do? You are supposed to first expand the numerator and the denominator. Alright? So we need to factorize the numerator, and that becomes 2x squared plus x minus 8x minus 4. Alright? And the denominator becomes x squared minus 4 squared as x tends to 4. So this becomes the limit of what's common, that is x into 2x plus 1 minus this place 4 is common, that is into 2x plus 1. Alright, then for the denominator we are going to have x minus 4 into x plus 4. This is called difference of two squares as x tends to 4. So here we have the limit of x minus 4 into 2x plus 1, alright, all over x minus 4 into x plus 4 as x tends to 4. So x minus 4 and x minus 4 we strike out. We are left with limit of 2x plus 1 as the numerator and x plus 4 as the denominator as x tends to 4. So we can now apply the limit. So we have 2 into 4 plus 1 all over 4 plus 4. 2 times 4, 8. 8 plus 1, 9. 4 plus 4, 8. So our answer is 9 over 8. And that is option D. So question 6, we have evaluate the limit of 3 tan x plus 4x over pi as x tends to pi over 4. So that will be lim 3 tan x as x tends to pi over 4 plus lim 4x over pi as x tends to pi over 4. So this will be 3 tan pi over 4. Anywhere you see x, you put pi over 4 plus that will be 4x, that's pi over 4 multiplied by 1 over pi. Yeah. So here 4 cancel 4, pi cancel pi. You are left with 1. Now don't forget that the value of pi is 180. 180 divided by 4, that's 45. Times 45 is 3, is 1. 3 times 1 is 3. Plus what do we have left here? We have 1. So the answer to this question is 4. And that's option C. Let's move to question 7, and that's the last question. We have this limit. If we are to do direct substitution of x as 1, that would be 1 minus 1, which will be 0, and that is a sin in limits. So what do? We can transform the denominator so that it looks like difference of two squares. I can have this. Yeah. By the time you expand this, you are going to arrive at 1 minus x eventually. So here I can strike out this and this so that I'm left with limit of 1 over 1 plus root x. Alright? As x approaches 1. So we can now do direct substitution. So this is 1 over 1 plus root 1. Root 1 is 1. 1 plus 1 is 2. So the answer is 1 over 2. And that makes option A the correct answer. Thank you.